You want to introduce us or not? Go ahead.
Investors, welcome on October 27, 2023. We are here doing physics in the AM.
In the AM. It's good. It's good. You should be a teacher. That was awesome, too.
October 27.
Okay. So we left off looking at this problem. Do we actually understand the physics concept of this, though? The whole idea that there's friction. Okay, flat friction doesn't really matter, right? As I take the cover of the book and start bending it, eventually there's that spot, right, where it just slid, right? Solder. This is the spot where it's just going to start to slip. So we're really assuming that the acceleration is 0. To make our math easier in some ways, our problem-solving strategy is to take the x-axis and put it along the ramp, the angle. That's our strategy. Because it makes it easier because that's the motion direction. It's going to be sliding down. So the force of friction will be down. By the way, my blue arrow to the left of the ramp is not a force, so it doesn't appear on. Okay, yes? Well, because gravity always works straight down, even if you're at an angle, right? So think of it this way. If you have, I don't want to draw this, right? But if now when I go like this, it's still way down, right? Straight down. You can tell that there's just, and I'm curling my finger a little bit, stop it sliding, right? There is some point down, but some of that, my hand's only pushing perpendicular. Right? There's some sliding to it. But the gravity strictly works down. Does that kind of make sense? Okay, so the gravity has to go down. And what we do, even though it wasn't explicitly asked, is you got to right away say, well, okay, gravity's working down. There's some component of it that's pulling it down the ramp, and a component of it that's equal and opposite to the normal force. We have to figure that out. And that's the first thing we do, the weight force. Break it down. We know by similar triangles, if this is 38 degrees, then this is 52. 90 plus, it all adds up to 180, right? 90 plus 38 plus 52 makes 180. So this is kind of where we left off. Figuring out the y component and the x component. And here's where people were befuddled. You can't actually come up with a number like 322 newtons. So we got to just leave it as an expression. And here's the other thing, and I added this in. I haven't quite gotten to this. Let me see if I can pull this, and pull this. Okay. We have these expressions. Now, you'll notice that I added in a negative sign here and a negative sign there, but I'm going to just take those out because it's crooked. Add in that these are negative. Why do I know they're negative? Let's take a look at the diagram. First of all, the hypotenuse, the gravity, hypotenuse, we really don't have a sign. It's not directly on an x or a y axis. But the x-axis portion is going to the left, so we're going to call it negative. The y-axis portion is going down, so we're going to call it. So that's why we're adding that in right now. This is where we left off. So I'm going to replace that. I put that too high. here is our y and our g, or y and our x components of gravity. The y-axis and the x. Now you want to come up with the coefficient of static friction. That's my green arrow. The friction force. We've got a ways to go though. We're really going to analyze the x-axis. So I'm going to say the x-axis. If you just put x-axis there. The sum of forces is equal to mass times acceleration. Which forces do we have in the x-axis? Friction, and the way I have it drawn, my friction is positive. Right? So I'm going to just call it FF. And then I'm subtracting the x component of weight minus FGX. Now this minus sign, I've put it in there, but that's this minus sign. I'm not going to double it up. Right? I'm just like trying to make sense of it. I'm saying that vector is a negative to the left. And that's equal to the x-axis, right? Oh, okay. Now, what do we know about mass and acceleration? We don't have a mass, right? So basically, but we don't need it because what's the acceleration? 0. Remember I was showing you just as it's going to slip. So I'm going to put 0 times m, so 0. I usually declare that right off the bat. If you know that it simplifies to 0, I just scratch it out right off the start. You don't have to do it there. It just saves you looking up things. Okay. And you notice that means that the friction force and the weight force in the x direction are equal and opposite, right? So I'm going to solve that. I'll put it down as this. Okay? Is that cool? Yeah, you said so. Now, I've already taken into account that this is negative, so I'm not going to double negative. If I had done it as a vector and I said plus, you know, we would do the double negative. But just understand. Force of friction, we have a formula, and we want to find the coefficient. So mu, then Fn is equal to Fgx. We have I'm trying to write degree there. Screwed up. There. You see what I did? I subbed there. Ouch. Still not any further ahead, am I? Oh, the force of friction is this formula, Fn times the mu. Whether it's mu k, kinetic moving friction, or mu x. It's always mu times Fn. Now I've got to see, do I have a normal force? I don't. My normal force is equal and opposite to the y component of gravity force. Does that make some sense? We've seen that normally with the flat thing, it's just equal and opposite to the weight force at an angle. So it's the y component of it. I'm going to replace Fn with that expression. Does that make sense? Why I'm doing that? This gets complicated. I understand. Difficult. So I'm going to go to mu. Then I'm replacing the Fn with this expression here. FG sine 52 degrees. Okay. What do you notice mathematically now? Yeah, the FG's cancel out. That's why we didn't need to know the mass of the weight. What that also means is that it's slipping, as long as it's the same substance, it doesn't matter. Oh, geez, I didn't realize. Tipping just showed us. Well, something. This is the angle that is kind of just sliding, right? Now, that means if I increase the mass of that, I don't know if I can do it. It'll still slide at the same angle. The book doesn't slide off. Oh, it slides off. I'm trying to say, okay, let's figure out this angle. Okay, that's about the angle that this slides at. If I double its mass or close to it, that'll be full. They don't slide apart. It should be the same angle, even though I increased the mass, right? Force of gravity doesn't matter for the friction. You get what I'm trying to say there? That's why that can't be done. It's independent of the weight. But anyways, back to the problem. We want to solve for mu, which is fairly simple now. Cos 52 degrees, sine 52 degrees. Are you guys in pre-calc? Who's in pre-calc? Oh, you guys aren't in pre-calc anymore? Nobody is? Oh, you guys are? Are you guys doing radian units yet? Okay. You guys know what I'm talking about. Okay, the whole thing about radian units is that if you come to physics class, when you do, make sure you're in degree mode for physics, and then the RAD mode for, but you're not in it yet. But once you start slipping back, you can do a whole test in the wrong mode and get every answer wrong. But I'd let you correct. Okay. So we're going to solve this. I don't know, you guys come up with it. You guys got calculators. I can't do that in my head. Yep. Oh, why isn't this FG sine 52? Because we're calling this the normal. So this is the FGY. This is FGY. That is down in the y-axis. But the normal force is the upper. It's the positive. So I subbed it in for the normal force. Equal and opposite, same expression, different sign. Yes? Oh, I see. Okay, what is the number though? You guys got to calculate. Yeah? Is that what you guys are getting? I don't know why it would be negative, first of all. You're in radian mode. See what I was just warning about? Okay. So that's what tipped me off. I can't do this in my head. I knew that would. Somebody help us out. Come on. Oh. Say it out loud. 0.78? Okay. That sounds reasonable. Anybody else to verify? Okay. Well, hey, good. whole thing to learn from this one is, sure, there's sine and cosine things, but if you're thinking that, oh, he didn't give us any masses or whatever, keep working with it. Doesn't mean that the problem is incomplete. It cancels out eventually. Now, thinking I'll do one more example if we need to. And you guys do. Do you guys think you should just skip straight to questions, or do you want one more example? One more example? Okay. Here it is. Jot it down. Okay, we've got this down. Already mentioned by one of my star pupils that the rise, I've got like 30 star pupils. Oh, right. One of my favorite stories is about 30. And I would never say that. Oh, yes, but anyway, 71 kilograms. Roofer. Stands on the roof. I'm going to draw this in here. Actually, I don't even have to be in a class these days. That says something. Oh, that's what I mean. He's the treat master. Okay. What's the frictional force the friction force, I guess frictional is kind of a made up word I made up, that keeps the roofer from slipping? Kind of. We have a mass this time. We don't have an angle this time. So this is where we're going. Let's go with the weight force is straight down FG, as usual. The normal force it can't be bigger than this, but I'm just drawing it. The normal force is this way. We know that friction works to the against the motion. We're cool with this, and it's assumed, but I'm going to just state this here. XY axis is on an angle. Right? Don't know what the angle is, but maybe we don't need to know. Right? Maybe we do, maybe we don't. Well, we typically, even though it's not explicitly asked, have to break down the, and yes, you do. What's going on? So, if I want to find the angle, we could do it two ways. I'm going to just show you something, but one way makes more sense than the other. We usually want this angle here, and it'd be like 30 degrees or something. The other would be 6. And we could say, well, we know the tangent is 1 over 3.5, and use the inverse function. But when we get to this diagram, we actually want this angle, which is here, right? You follow that? Bigger one. Because that's the one that'll help us do our sine to cosine. So according to this is opposite, and this is adjacent. You guys follow me on that? So let's skip doing the other one. Go straight into this theta here, which is this theta. Opposite 3.5 over 1. They're both meters, so the meters cancel out. Okay? I can't do that in my head, but I'll bring up the calculator to do it. Okay, got my calculator up. I know I'm in degree mode. So what I'm going to do is 3.5 divided by 1 is 3.5. So I get 74.1 degrees. Now I can do my FGs. Right? What'd you get? Okay. 0.5 bumps it up to decimal one.
Oh.
Okay. Before we start, maybe I'll figure out what FG is. MG. We have a mass, so I can do that. 71 kilograms on 9.8. I have it worked out. Here's 696. Okay. Is that cool? Not 20 times. Kilograms times meters per second squared. mg, mass times gravity is acceleration. Weight force is gravity. On Earth. Fg is the weight force. It's mass times gravity.
Oh, you just say your thing.
I got you. Oh, I didn't work downwards. You're right. I normally do. I don't know why I did that. Okay. Obviously you don't. Because I could do. Okay. FGX. FGY. Let's get our FGX. We know that we can just use the cosine with the 696. So I'm going to just go 696 cosine of 70.1 degrees. Haven't the foggiest what that is. I'm going to set up the other one and then do them both. I'm actually going to let you get it. I'll wait for answers. Do we have values for this? You know? Back table. Next. Thank you. And now, one thing, and then I always insert these after. I look at my diagram. Typically, I set it up so that my diagram, my ramp, I usually have going down to the left. But I know both of these are negative. I'm going to just insert those negative signs in there after the fact. It only depends on how you drew your diagram. If I had my ramp angled the other way, my x component would be positive, right? So that's dependent how you draw it. Okay. Now, example of a problem where we didn't have the angle. We still want the friction force that keeps, I don't know why, frictional force. It keeps the roofer from slipping. I don't need the mu value to do this, do I? The x-axis. The sum of forces this always gives you a mark. And we don't want him to slip. Right? So that means what? Acceleration? We're not using the same excuses. Yes, okay. Sure. Now, on my diagram, the force of friction is to the right, and the F gravity, the weight force X, is to the left. So I'm going to use the sign built in right now. F minus F X, the force of weight. This means they're equal and opposite. I've already taken the sign into account, so I'm just putting in numbers. We're just trying to find FM, so I'm not going to put in UFM. I've already got this figured out. 190.7. The sig fig wise, I'd actually put 191. I'm not going to hound you on sig figs right now. These are difficult enough. I've talked to you about this. You're going into engineering or some science program, you can figure it out then. I keep modeling. That's actually only 3. Stuff like this. Anyways, now your problems. Stop the recording once I give you the problems you're going to work on. Are page 133, 33 through 37. I'm going to stop the recording. I'm going to make a plan with Desmond.